Welcome back. In this video, you will understand data cleaning. Data cleaning is also known as data preprocessing. One of the concepts in data cleaning is missing value. What is a missing value? A missing value is that there is a data point that is missing in your data set, and Python identify a missing value by using NA, NaN, or null. And to check a missing value, Pandas has many functions such as isna or isnull. You may also want to identify the number of missing values in your dataset, and we have these functions to help you do that. And the function is isna.sum, which will give you the number of missing values in each of your variables in the dataset. So let's see all of this in action. So I'm going to open a Jupyter Lab notebook called Pandas 3. Remember that you have to go to your snippet codes for CS22 and then open Pandas 3 to follow along with me. In order to see this video clearly, I'm going to close this so that you can see everything at a glance. I'm going to import a dataset called Somalia Women CSV. So before I import that dataset, I have to import different packages that will allow me to work with this dataset. So one of the package is NumPy. Remember, we have to import NumPy by using import NumPy as np. And for data importing and all of that, we also need to use Pandas package. Remember, to import Pandas package, you have to write import pandas as pd. So let me run all this. As you can see, it's running. The code cell is running, as you can see. Now, our packages are now ready because they've been fully loaded. I also need to import my data set, which is Somalia Women. The data set contains the height and weight of Somalia women. So let me import it. So this data set is at the data set folder. As you can see, if I go here, if I look at data folder, you will see Somalia Women CSV there. This is it, as you can see, Somalia Women. And I'm going to use pd.read_csv to import that. So let me run my code cell. Now my code cell is run. So let's see the first 5 observations in this dataset. So in that case, I will be using the .head function to do that. As you can see now, I can see NaN here, which is a sign that there is a missing value in this data frame. It is not always that missing value will be at the starting point. No, you only see the missing value here because our data frame contains a missing value. But let's see whether truly there are many missing values in this data frame. So we are going to use is.na for our data frame in order to see whether there is a missing value or not. So I'm going to use isna attribute to see whether there is a missing value or not. So I do like this, isna. As you can see, I have series of true or false. As you can see, true, false, 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 and all of that. So the false represent there is no missing value, while the true represent there is a missing value. There are also another attribute that can help us see whether there is a missing value or not, and that is null. It means that you have two attributes that do the same thing. So it's either you use is any or is null. So now let's see how many missing values are in each of the variables. So in that case, I have to use .sum attribute in order to see the number of missing values in my data frame. So let's see it. Remember, you have to put your data frame here, which is the Somalia woman. As you can see, Somalia woman. Then you use dot is NA. Don't forget to include the parentheses, otherwise you may get an error. So after that, because this one will give you series of true or false. So after you have done this, then you will now put the dot sum attribute. As you can see, dot sum. Then you close the parentheses. And if you run this, now you will now see the number of missing values in each of the variables. You can see that the height variable or height series has 4 missing values, while the weight series or the weight variable has 5 missing values. Is that interesting? So let's see another data frame. In this case, I will be importing police shooting dataset. Remember, my dataset is at the dataset folder. That is why I am including it here. And one thing about this dataset is that it's an Excel file. And you know, to import an Excel workbook, you have to use Pandas function called pd.read_excel. And that is exactly what I do here. So I'm going to run this. As you can see, it's loading. Now it's completed. Remember to see whether there is a missing value or not. I can use isna, and isna will only return series of true or false for my data frame. But in order to see the precise missing values, I can now use dot sum against that, so that it can give me the number of missing values in each of my variables. And that's exactly what I do here. Now you can see that we have missing value for armed, we have missing value for age, we have missing value for gender, we have missing value for race, we have missing values for longitude and latitude. While the 0 indicates there is no missing value. As you can see, what you need to master is just all this. It's NA dot sum, and that's all. You now get your result. Welcome back. In this video, you will learn data imputation. What is data imputation? Data imputation is a process at which you treat your missing value. And you have two ways at which you can treat your missing values. So the first one is to get rid of them, either by row or by column. For example, let's say in the Somalia woman data frame, as you know, we have two columns, which are the height and the weight of Somalia women. Let's say there are missing values at the height column. So the first method here says that you should remove that, and that's exactly what the get rid method will do. The get rid method will remove the missing values either by rows or by columns. Another good way at which you can treat your missing value is what is known as data imputation, and that is the process at which you replace your missing value by a known value. A known value could be replacing it by the higher value, which is the maximum value, or replacing it by the average value, which is the average of all the values that are present and that are known in the variable. So let's see them one by one. The first method to treat is getting rid of a row or column that has a missing value. I will be using Somalia woman to show that. In the Somalia woman, as you can see, we have the height and the weight of Somalia woman. And before I get rid of any missing values, let's see the number of dimensions in this data frame. Remember, to get the number of dimensions, you will use the dot shape attribute. So in this case, I run this. As you can see, we have 250 rows and 2 columns. And to see the number of missing values, we are going to use this attribute, which is isna and dot sum all together, as you can see. Now, as you can see, we have 4 missing values at the height column and the 5 missing values at the weight column. In order to get rid of any missing values by row, we can use the attribute called dropna from Pandas to do that for us. So let me do it. As you can see, this is how to do it. You will just put this attribute against the data frame, and I'm saving the result as this, which is Somalia woman drop na. So if I run this now, every missing value in this data frame will be removed automatically. So now let's check the remaining dimension after we have removed those missing values. Now let me run it. As you can see, now we are now left with 241 rows with just 2 columns. So if you look at or you consider the previous dimension, we have 250 rows and 2 columns. And after we have removed some missing values in that data frame, we are now left with 241 rows. Sometimes you may want to remove the column that has a missing value, and we will see it in action now. So I am using the East Africa names dataset in order to show you how to work with that. So look at your datasets folder and specify the East Africa names so that you read it. There's a problem in that dataset, and the problem is known as encoding problem. That is why we are specifying this in order to be able to import it successfully. So I run this. Okay. Now let's see the head of this data frame. The head of the data frame is this. As you can see, it contains names of people in East Africa. And some of them, as you can see, Adan, Adam, Aden, Amina, and Abada. You can also see their gender. For example, Adan is a male, while Amina is a female. So one other good thing about this dataset is that it also contains the origin where they have derived those names. For example, Adan is from Somali. And as you can see in this one here, so other origins are not available because they are missing. So which means that this Adan is solely from Somali. You can also see another name called Adam. It's also a male, and you can see that the name is from Urdu or Somali or Estonian, and that is how every name is being represented in this data frame. Now let's see the number of missing values in the data frame. Remember, to get the number of missing value, you have to use isna with some attributes. So let's run it together. You can see that we have 970 missing values in the origin 2. We also have 1093 missing values in origin 3, while we have 1116 missing values at the origin 4. So let's see how we can drop columns that have missing value in this data frame. We are going to use the drop na pandas attribute to do that. So one thing we need to note is that we are going to specify the axis at which we want to remove. Remember, in the previous examples, we don't specify axis. In that case, only the rows that has missing values will be removed. And when we are specifying the axis column, then it means that only the column that has missing values will be removed. Now let me do it. Before I do that, let's see the initial dimension of this data frame. So I will be using the dot shape attribute to get that dimension. Now you can see that we have 1116 128 rows and 6 columns in this data frame. Now let me call the dropna by specifying the axis equal to columns to specify that remove any column that has missing value in this data frame. So I'm going to run this, and while doing that, I'm saving the new data frame as East Africa dropna. So let me run it. Now you can see that I now have just 3 columns, which are the name, the gender, and the origin at which those names are being derived from. So if I call the dot shape again to see the new dimension that I have, you will see that I will only have 1128 rows and 3 columns, in which you can see already. As I said previously, that we have what is called data imputation. And data imputation is the process at which you replace any missing value by a known value. And the known value could be a mean or the median of the whole variable or the maximum or the minimum of the variable. So let's see how we can imputate any missing value in our data frame. I will be using Somalia women in this example. So let me see the overview of it. As you can see, this is the Somalia woman head data frame, and you can also see the number of missing values. And before I inputted that, so let's see the average height of Somalia women. In that case, I will be calling the column height from the data frame, and then I will be using the dot mean attribute to get the average height of Somalia women. So let me run it. As you can see the result here, the average height of Somalia women is 64.7. And this is the average that we will use to imputate our missing value in the height column. I'm also getting the average weight of Somalia women by using the weight column. As you can see, remember in the previous video, I've shown you how you can extract a column from the main data frame, and that is exactly what I did here. And I now call the dot mean attribute in order to get the average weight of that column, and that is what I have here. So if I run it now, you can see that the average weight of Somalia women is 64 lbs or pounds. Another way at which you can get the mean of every column in our data frame is by calling the mean attribute against the main data frame, and that is what we have here. So if you do this, you will see that you are getting the mean of every column. For example, the mean of height is 64.7, while the mean of weight is 64.1. And this is different from this because this method is only calling the column height from the data frame. And in that, we are now getting the individual mean of this height. The same thing with this. We are calling the weight column from the Somalia data frame, and we are getting the average weight of that data frame. As you can see, this is it. While this method will only give us, individual column mean, and that is what we have here. And this method is actually better than the other, and you will see it when we continue. In order to imputate any missing value, we are going to call the fillna attribute. The fillna attribute from Pandas enables us to imputate our missing value, by using a known value. And you have seen here that we've already seen our known value. For example, for height, we are having 64.7. So if you use the mean, it means that every missing value in the height column will be replaced by 64.7, while every missing value in the weight column will be replaced by 64.1. And let's see how to do that. So I'm going to call the resulting data frame by Somalia women input, as you can see, and I'm using the original data frame, which is Somalia women, and I'm calling the fill any attribute, which will help me to really imputate any missing value by using the average, average height or average weight for that column. And that is exactly what I did here. So if I run this now, as you can see, every missing value has been replaced now. So it means that any missing value in the height will be replaced with the mean height, while every missing value in the weight column will be replaced with mean weight. And that is exactly what we have here. So now, if you now call isna.sum in the resulting data frame, you will see that there will never be any NA again. Now you can see for height we are having 0 NA, and for the weight we are having 0 NA. Welcome back. In this video, you will learn another process at which you can clean your data. In this case, you will be identifying whether there are duplicates in your data frame or not. So let's see how to do that. The first thing to do when you are doing a new data science project is to import your packages. And in this case, I will be importing NumPy and Pandas all together. Now that my packages have been loaded, I want to import another data set called course attendance. This is a data set that contains the name, the gender, the age, the country, the course taken. And let's see how to do that. Remember that our dataset is a dataset folder. And so when you are importing it, please don't forget to include dataset in the part of your file. So let me run it. I'm saving the result as course attendance. And to see what is saved in this, I can just call this. Now you can see the whole dataset at a glance. So let's see how to identify whether there is a duplicate in our dataset. What is duplication? Duplication is a process at which an item appears more than once. For example, you can see that we have different gender, which are male, female, and so on and so forth like that. And also for the country, as you can see, we have Somalia, Kenya, Somalia, Sudan. You can see that there are some duplicates in country, which is normal. But let's say that you want to identify whether a particular observation appears more than once in your data frame. That is where you can now start taking care of those duplicates. So let's see whether we have duplicates in our data frame that we just imported. So let's see. To do that, we are going to use an attribute called duplicated. Duplicated here will give us just two values, true or false. True means there is a duplicate in that observation, and false means there is no duplicate. As you can see now, if I run this, now I have all this. Okay, so let's see another step, because it actually has two steps, and I'm showing you the first one, which is the dot duplicated attribute. The second step is that you will now include the dot sum attribute so that you can see the number of duplicates in your data frame. And in this case, I'm adding the dot sum attribute against the duplicated attribute. And now if I run it now, you can see it's telling me that there are 3 duplicates in my data frame. One good thing that you may want to look at is to identify where those duplicates are and what are the observations that are duplicated. And to do that, we will do it in this way. The first thing to do is to first of all call your data frame. And in this case, I'm having course attendance. Remember, we have this, okay, which gives us the number of duplicates in our data frame. So if I put this against this square bracket, it will then return those observations that are duplicated in my data frame. Now, if I run it now, let's see. As you can see, I now have those observations. To be precise, what I need to do, I'm not going to include sum. I will only include cost attenders duplicated, which we have done here in the step 1. And remember, that one gives us the series of true or false. As you know, false means there is no duplication, while true means there is a duplication. So now, if I just do it as I do it here, okay, I run it now, I now have those values that are duplicated in my data frame. As you can see, it's interesting, right? It's actually very simple. You have just two ways or two steps. The first step is you call your data frame, and in that your data frame, you now put a square bracket, which is this, and in that you now put the data frame with the dot duplicated attribute, and that one will now return those duplications that are in your data frame. Let's see another example. This example is like what we have done before. Remember, in the first example, we want to know whether there is a duplicate or not. And I said we have two ways to do that. So the first step to take is to use the duplicated attribute, which returns the series of true and false. And in the step 2, we now use a square bracket inside it, as you can see, to really identify those duplications. And one good thing we can do is that we can actually do it with one line of code, and that is what we are doing in the second example. I hope you now understand it better. So which means that you don't need to start, looking at the true or false. Instead, you can just use one line of code. And this is it. You call out the data frame and you put a square bracket. You call out data frame again and you put the dot duplicated attribute against that your data frame, and you will now have the result as it is here. Another example is that you may want to select duplicate rows based on a particular column. For example, I want to identify those duplication by name. For example, as you know, in my data frame, I have many names, and I want to know the name that appear more than once. And that's exactly what I'm doing here. As you can see, I call out my data frame, I put a square bracket, I call out my data frame again, and in this, I call out the duplicated attributes. Because the duplicated attribute has one argument, and that argument, if you don't specify it, in that case, it will only show you, observations that are duplicated. But if you specify something in that argument, then duplication will be treated by that column that you specify. So in this case, I specify the column name inside it, which means that it will only identify any duplication by the column name, and that is what I have here. So this one is showing us that Francisca repeated in our data frame. You can also see that Francis also repeated more than once in our data frame, while Simon too repeated more than once in our data frame. Let's see another example where we will see a duplication that appear in the cost taking. Remember, cost taking is another column in our data frame. So I just repeated my code and I changed the name to cost taking. Now I can see those cost taking that appear more than once. For example, CS13, CS22 that we are doing now, CS15, CS12, CS16, and so on. Okay, let's see the last example where we want to identify duplication by more than one column. So in this case, I want to see duplication that appear by name and by country. Now, as you can see, just the same thing. You call out your data frame followed by a square bracket, and inside that square bracket, you call out your data frame again, and you also put an attribute called duplicated. Alright, and inside that duplicated, you will now introduce a series, as you can see here. And inside that duplicated argument, you will now introduce a list. As you can see, inside that list, we now specify the name and the country. So what we are doing here is that we want to identify duplication by name and by country. Now you can see here that Francisca appear, and Francisca is also from Uganda. So which means that the observation that has Francisca and from Uganda appear more than once. We also have another one here, which is Francis, and that one is also from Kenya, as you can see. So here now, we are now comparing that, okay, Francis from Kenya appear more than once, and also Francisca coming from Uganda also come more than once in our data frame. You can also see the last one here, which is Simon. Simon is from South Sudan, and that one also appear more than once. What does that mean? It means that maybe Francisca from Uganda, are taking more than a course. That is why it appear, because if you take more than a course, of course it will appear by name and by country as well. I hope you have now mastered how to identify whether there is a duplication in your data frame. Remember, we have the dot duplicated to help us do everything. You are welcome back. In this video, you will learn something new, and it is data exploration or exploratory data analysis. Exploratory data analysis, also known as EDA, is an approach by data scientists to analyze and investigate data sets by summarizing their main characteristics by using various data visualization methods. In a simple form, the main idea of EDA is to help look at data and see what it can tell us before making any assumption. EDA also helps us to identify any obvious error, as well as understand the pattern in your datasets. EDA also allows us to detect outliers and find interesting relationships among different variables. In this video, we will see how to use pandas to explore our datasets. But before we start that, let's see what pandas profiling has to offer us. What is pandas profiling? Pandas profiling is a Python module that extends the Pandas data frame. So which means that majority of the work that we'll be doing here, we'll be using another module called Pandas Profiling. So to use Pandas Profiling, you have to install it first. Now let me show you how to install Pandas Profiling. To install Pandas Profiling, you have to use this code, which is pip install pandas profiling. Please look at it carefully. Pip install pandas. You can see that there is an hyphen here. So there is an hyphen between pandas and profiling. Or you may want to launch your Jupyter Lab notebook by coming to pandas 5 so that you can easily copy and paste. So just copy this guy. Okay, then to actually install it, you have to open your Anaconda prompt. As you know, I have already launched my Jupyter Lab notebook, and that is why I won't be able to use my Anaconda prompt again. But there is another way to do that. In order to do that, you will click on File, then you click New, and then you select Terminal. As you can see, you now have a terminal. So in that case, you then paste your code, which is pip install Pandas Profiling. Whenever you are installing a module, make sure that you have your internet connection available, or make sure that your computer is connected to the internet. Now, as you can see, everything is now installed on my computer. Okay, you may also want to try it. Okay, what you just need to do is to put this code there, which is pip install Pandas Profiling. Now I have it. So I can go back to my pandas notebook, which is pandas 5. Now that I have installed Pandas Profiling, so let's see how to load it. To load Pandas Profiling, we'll be using from Pandas Profiling import profile report. This is it. From Pandas Profiling import profile report, and that is exactly what we want to do. So I'm also adding other packages which are NumPy and Panda. So I'm running these guys all together. Okay, as you can see, it's loading. It's loading. Sometimes it takes some minutes or some seconds to fully loaded. I'm going to fast track this video. Now it is finally loaded. So to use this Pandas Profiling, I will use an example called Ethiopia flowers dataset. So let's load it. So we are using pd.read_csv to load this Ethiopian flowers dataset. So I click on it, as you can see, now it runs. In order to use Pandas Profiling, okay, I will be using an attribute called profile_report, and this is what will now do all the data exploratory analysis for me automatically. So let me do it. Remember, my own data frame is called Ethiopian flower, and that is it here. Then I am calling profile report on it, as you can see. Don't forget to include your parentheses. So if I run this now, let's see what will happen. As you can see, it's loading for me. It's loading, and then you now see several data visualization that will appear: histogram, bar chart, scatter diagram, and it will do it automatically for all the variables in our data set. As you can see now, it's very good. You can see it's telling us the overview of our data set in terms of the data set statistics. As you can see, it's telling us the number of variables, the number of observations, if there is any missing values. As you can see here, there is no missing cell. It's also telling us if there is any duplication in our data frame. As you can see now, if you look at the previous video, you know that we are using a code to get whether there is a missing value or not. And here now, Pandas Profiling is doing everything automatically for us by just using .profile report. You can see it's telling us the number of memory that we have used. Okay, and you can also scroll down to see those variables that it has done data visualization for. As you can see, this is the stepper length. You can see the histogram. You can see those statistics in form of minimum, maximum. You can see if there is any missing value in this variable. You can also go down. You can see stepper width, the histogram, and all of that. So interesting. As you can see, petal length. You can see all of that. You can also play with all this by clicking on toggle detail to see it, in terms of statistics, histogram, common values, extreme value, all of that being automatically done for you. You can see petal width, you can see species, and if there is a categorical variable, it will only draw a bar chart. If there is any continuous variable, then it will plot histogram for you, as you can see it here. And it's also showing you some interaction. As you can see, this is a scatter plot or scatter diagram to show whether there is a relationship between the variables. You can also see for the separ width and all of that. So interesting. And also, it's showing you the correlation coefficient in terms of Pearson correlation. Don't worry, you will see all of this in details in CS31. Now, this is the heat map to show the correlation among several variables. And for missing values, it's also showing you here if there's a missing value and all of that. It's also showing you the first 9 observations in your data frame and also the last 9 observations in your data frame. Remember, to do this by yourself, you can use dot tail, and for the first observation, you can use dot head. And this is exactly what Pandas Profiling is doing for you automatically. As you can see, so which means that this Pandas Profiling is actually very good. It's a good toolkit that you may want to add into your toolkit. Let's see another example where we'll be applying Pandas Profiling. So in this case, I'm importing a data set called money transfer transaction. And you can see this data set at the datasets folder. So let me import it. I'm importing it and I'm saving the result as money transfer. As you can see, it's loaded, and after the data frame is already set up, then I can call this profile report. It's an attribute, profile underscore report. Then you close the parentheses and you run it. And it now generate a lot of statistics, a lot of data visualization for you. And this makes it so interesting. It's a good toolkit that you must add into your tool. I'm telling you. As you can see now, you can see the overview of the data frame in terms of number of variables, just like what you have done before. You can see different visualization in terms of what variables are existing on your data frame. As you can see here, gender. You can see that in this data frame we have 297 females and 203 males. You can see the distribution of the age. You can see the direction, whether it's an inflow or outflow. This Pandas profiling is so good. It's so fantastic. And I believe you are also enjoying it as I'm enjoying it here, because I'm so excited to know how to use Pandas profiling. As you can see, it's also showing us different correlation in terms of the heat map and all of that. So that is exactly what Pandas profiling does for our data frame. Welcome back. In the previous video, you've seen how to use Pandas profiling to create different exploratory data analysis of your data. In this video, you will see how you can summarize your data. Precisely, we'll be using the .describe attribute to get the descriptive statistics of our data. So let's begin it. I'm going to import a data set called Somalia women. So let's import it again. Now that I have imported Somalia women data frame, let's see how to use that .describe attribute. So what we will do is you will call the .describe attribute on your data frame .describe attribute. Okay? And this is what you have. And what does it do? The .describe attribute gives you the summary statistics of your data set. Now you can see that you have two continuous variables in your data frame, and they include height and weight. Now you can see all the description here: the count, the mean, the standard deviation, the minimum, the 25 percentile, the 50 percentile, the 75 percentile, and the maximum. That is exactly what .describe attribute does. Let's see another data frame. In this case, I will be importing a dataset called East Africa Names dataset. Remember that this dataset is having an encoding problem. And to solve that, we are using encoding argument of the pandas read underscore CSV. So let's run it. Now we have the answer. You can see that our data frame here does not have any continuous variables. Everything there are just categorical variables. For example, the name, the gender, the origin, and all of that. So if you call the dot describe attribute on this data frame, we will not see what we saw in the last example where we are seeing all the summary statistics like count, mean, and all of that. So let me show you how this one will look as. So if I run this now, you can see I only have the count, the unique, and the top, and the frequency. What does that mean? That means that we have just 1,128 names, and we also have 1,128 gender, and you can see for other variables. So the unique here is just talking about the uniqueness, that is, there is no duplication. So for example, now we have 1,047 unique names. You also have, as you know, gender is just male and female, and that is why we have two here. And we also have the top. The top means the most highest frequency, that is a particular value that appears most. So for example here, under the name, we have Ambessa, which appears most among different names that are present in this data frame. And you can also see the frequency and all of that. So let's import another data set. So here we are creating this data frame from scratch. Remember, in the first video of this module, you've seen how you can create your own data frame from scratch. So the first thing is to first create a dictionary, and dictionary will contain key and the values. You can see now we have key, which will later become the column of your data frame. So we have key gender, we have key country, and we also have another key called age. And now I'm also calling pd.data frame to create a data frame from this dictionary. So let me run it. Now that I have run it, you can see how the data frame looks like, as you can see it here. Now, what I want to do here is that I want to extract the gender column from the data frame, and I want to call the dot describe to show you what we have seen in the previous example here. You can see that when I call the dot describe, I call it on the data frame. But here now, I am calling the dot describe on just the column, and that is why I'm having this. And if I have done it directly like this, I will have something like this. So let me say registration data frame dot describe and see what will happen. You can see what happens here is that it only does it for the continuous variable in that data frame, and because there's no way you can do it for both continuous variable and categorical variable, that is why this guy had to do it only for the categorical variable. Okay, although there's a way at which you can also specify it to do it for only the categorical variable, but this video will not show you that. Let's see how we can see the frequency distribution of a particular variable in our data frame. In that case, we will be using an attribute called value count. Value count will give us the frequency distribution of that variable. So in this case, I am calling gender column from a data frame, and I'm now using the dot value counts. Remember, it's value counts and not value count, because if you use value count, you will get an error. So if I call it now, you can see what I have. Now I have the frequency distribution. For example, I have females that are just 6 and men are only 4 in this data frame. Let's see another example. In this example, I will be using the East Africa names data frame. We've already imported it, so the data frame name is called East Africa. All right. And in this case, I want to call the value count on the gender column. Remember, I have called the gender column here, and I specify the attribute value count. If I run it now, as you can see, here now I'm having 614 males and 514 females. That is exactly what the value counts does for us. What it does is to give us the frequency distribution of that variable. And sometimes, let's say that you want to get the percentage distribution. In that case, you will be using what is called normalize. So you specify normalize to be true in the value count argument. So let me do it one by one. So in this case, I'm going to create a new cell and say East Africa dot, remember I can say dot gender, but don't let me use dot gender because I have told you not to use dot gender. So in this case, I will just do like this. I just call gender, okay, and then I say value counts, value counts, value underscore counts, okay, and then you can just say normalize. Normalize is equal to true, and this will give you the percentage. Normalize is equal to true. If I run this now, see what I get. I now get the percentage distribution. Now you may be asking, this is not like percentage. Of course, you can also multiply it by 100. If I multiply it by 100, I now have this. You can see that males contain 54.4%, while female contain 45.56%. And at times, you may want to sort your result in either ascending or descending order. That is why we have this argument called sort. So if I just delete this guy, it will sort it, in descending order. As you can see now, 614 for males, 514 for females. And if I want to sort it by the percentage, then I'm going to include normalize equal to true in my argument. Okay? So if I run this, and now I'm getting an error because I misspelled the normalize. So now I cannot say normalize equal to true. Now I get it. Alright, so we've already done this one before. This is where we are calling the gender column and we are getting the percentage distribution of the gender. And now you can see that we have 54 are males, 54% of males, and 45 percent of females. I hope that you have mastered how to get the descriptive statistics of your data frame. And in this video, we've seen how we can use the .describe attribute and the value count attributes. Thank you so much for watching this video. See you in the other video. Bye.